In this video, we're going to take a look just a little bit more in depth at polar conversions, which is where you can take something in rectangular form and convert it into polar form. Now, most commonly in your homework and on your test, you'll be asked to convert one point from one form to another, or a whole equation from one form to another, and it's a two-way street. It might be rectangular, and you're asked to convert it to polar, or from polar back to rectangular, and the same thing with points as well as equations. So let's remind ourselves how this works exactly. We looked at these conversions in a previous video, but based off of a point like this generically that has an x, y coordinate and an r theta value, then the conversions go like this. X equals r cosine theta due to the right triangle that we have here that's made between the origin and the x-axis. The y equals r sine theta, and that conversion again is from the right triangle that we have. X squared plus y squared equals r squared. That's again from the right triangle and the Pythagorean theorem. And tan of theta equals y over x. That's one of those trigonometric ratios that we learned some while back. So these four here will be helpful in converting x's and y's into r's and thetas, or the reverse, r's and thetas, turning them into x's and y's. All right, so in this particular video, we're going to do one example with points and another example with equations. All right, so let's start with the points here. So what we have for this example is a polar coordinate r theta 4 comma negative 2 pi over 3, and I would like to write this in rectangular coordinates, which is in terms of an x and a y. Okay, so what would this guy be in terms of x and y? All right, so for the x, I remember that the x was equal to 4 times the cosine of theta, which in this case is negative 2 pi over 3. And the y would be equal to 4 sine theta, or 4 sine negative 2 pi over 3. All right, so the biggest thing I think I have to do now is just remember where negative 2 pi over 3 is. So let's think about this. Positive 2 pi over 3 from the positive x-axis would be right about here. But on the other hand, negative 2 pi over 3 would be right here, which has the same terminal angle as 4 pi over 3. So on your unit circle, what is, and I'm asking this as a question, what is cosine of negative 2 pi over 3? Or in other words, what's the cosine of 4 pi over 3? Well, hopefully you said negative 1/2. And 4 times negative 1/2 would give you an x coordinate of negative 2. All right, and on the other hand, the sine of negative 2 pi over 3 would be negative root 3 over 2. So we'd have 4 times negative root 3 over 2. And multiply those two, and you would get 2 times negative root 3, which I'll tell you what, let's move that negative out front and have negative 2 root 3. So this is your x and this is your y coordinate for a point written in polar form with this particular r theta, value for r and value for theta. So that's how we convert one point to another. You simply just go down this list and choose the appropriate one. Now let's try one in kind of more of an equation format. All right, so same conversions and all that good stuff, but this time we have to convert r equals 6 cosine theta to rectangular form. So let's think about this. When I look at my list of conversions, the only one I see that it could remotely be is the first one, at least on one hand, because this is the only one that has a cosine. Now, one thing concerns me though. My equation does not have an r with the cosine, it's just a cosine. I really need an r for that right hand side right here. Something else that concerns me a little bit is on the left hand side, I have an r, But if you look at your conversions, I don't have any conversion for just an r. I've got an r cosine theta, I've got an r sine theta, and I've got an r squared, but nothing that's just an r. So this r squared looks like the closest thing I have, but really he needs an extra r on this side of this guy too. Well, this is a little trick, and so hopefully you can implement after you see me do it once or twice. If you need an r on the left hand side and the right hand side, make everybody happy and give both sides an r. Then what happens is the left side becomes r squared and the right side becomes 6r cosine theta, and everybody's happy because now you can convert both of these into rectangular form. All right, so what is the conversion for r squared? Well, it would be x squared plus y squared equals, okay, and that's all you have to do is take out the r's and put in something equivalent in terms of x and y. And then 6r cosine theta, well, hey, that's just 6x, right? And so this is your answer. I've converted the equation from polar, this started off in polar form and ended in rectangular form. That's literally all we have to do. If you wanted to take it farther, you could subtract the 6 to the left and then complete the square and do some other things. But at the end of the day, this is a good simplified version of what I was looking for. All right, so hopefully that helps you understand conversions just a little bit better. And like I said, this is typically what happens. Sometimes we convert a point to a point. Sometimes we convert an equation to an equation. So anyways, hopefully that helps you understand conversions between polar, rectangular coordinates just a little bit better.